your result. Okay, so you can use for your entire subject and also for your next or your incoming subject will maybe use PSIM or other kind of simulation software, and maybe for your career later on. So as you can see from the slide here, the objective of this task or this lab module is to get yourself familiar with PSIM, how to create, how to compose and simulate, analyze, and how to compose the circuit, how to simulate the circuit, and what you will expect from the simulation. And when you get the result, how you want to analyze, how you want to present the circuit. So for this task, for this subject, we are focusing more on power electronics application, converters. Converters. So this kind of simulation or software tools can be used elsewhere in other subjects also. Okay, if you go to the schematic, targeted schematic, so we have here, we have load, and as what we discussed before, for converter, we shall have a load. Maybe we have a, sorry, I don't have my pen right now. I'm using cursor instead. So let's say we have load, resistor load. Then we have our source, AC source, and we have AC source. So then we have to supply the load, and we have to supply the load from the AC source with the shape of current or voltage waveform that the load requires. So what we have to do is that we have to put a converter in between the load and the source. Okay. So for this task, the load is varies between resistive, inductive, capacitive, and impedance. So you have 4 groups now. So each of your group will compose different kind of load and present in terms of their circuit the results that, or the shape of the voltage and current that produced out of the circuit. And so means that you measure the current here, how the current flows in terms of the pattern. You measure also the voltage that flow into the load, and you analyze what kind of result you obtain in terms of the peak average RMS readings, and you give the discussion in terms of what you have seen or you observe from the simulated output. Okay, so the marks here represent how details you want or you have to present or you have to explain and to the audience. Okay, we shall learn from maybe the discrepancy that we do, or the mistake that we do. So we are not expecting to do mistakes lah, but every mistake that we do, we shall comment and hope that the same mistake will not be repeated in future. So the appendix here we have has a reference. So means that for resistive load, this kind of the result that you should have or obtain at the end of the simulations lah. So for inductive, capacitive, and inductive. So each group will present these 4 different elements of load: resistive load, beban resistive, beban inductive, capacitive, and impedance. So it based on the group of 3B2, B3, B4, and B5. Okay. B2 Anis dengan Khairunisa, B3 Anas Nabilah, B2 Anis Khairunisa dengan Anas, B3 Nabilah dengan Nurul Nabilah, B4 Mahmud Aden Abdul Syakur, B5 Hisham Badrul Munir dengan Ahmad Nabil. Okay, any question? I shall give you 10 minutes for your task, and then every group will present to the audience. You have to present in 2 to 3 minutes. Then we shall comment based on your presentation. Okay. Ada sebarang soalan? Any question? Then we shall proceed after that with part 2 directly today. We expect to finish within 1 hour lah today. Tak perlu sampai 2 jam. Okay. Any question? All okay?
Doctor.
Mahmud Aden,
Doctor, I have two.
Yeah.
Yes, Doctor, I have the installation problem for Pixim Lab.
You cannot install PSIM yet, or what?
The installation, sorry.
So actually you have to
not yet,
reinstall
because
again.
of cleaning the computer.
What happened to you?
Yeah,
What
because
happened?
I cleaned the computer.
Oh, your computer problem.
Because it's too heavy for. Yeah.
We have the size of the file is, I think, 285 megabyte. You don't have that space.
Yeah, I will reinstall now. Internet for the, because the weather I'm not sure.
You stay
the
at
raining.
which?
Sorry.
No, you stay where? PF2.
The area of Ulubao. No.
Ulupau, yeah, area outside lah, not in PF2.
Yeah,
Okay,
not
never mind.
outside
You
of
PM me.
the Unimap.
You private message me.
Okay, okay.
Try to install as soon as possible. But
okay,
other group,
okay,
please proceed with your
okay.
with your simulation within 10 to 15 minutes. I think we shall start presenting at 3:25 now. 3:30, 3:30 lah, 3:45. Okay. 3:45 kita akan present based on group 3 yang ikut turutan tu lah. Group 2, 3, 5. Abdul Shakur, you try. Maybe you are the final group to present. Okay?
Okay, Doctor. Okay.
Okay, please proceed. I'm here. If you have anything, you can ask Rujimit. Okay, please proceed. Thank you. Okay, guys. Okay, please, G group B2. Okay, you may start your presentation within 2 or 3 minutes. The others, please listen. We shall discuss the presentation as well for you all to hear what are the comments. The best known method that we should follow in our presentation and our report. Okay, please B2. B2, Anis, Khairunisa, Muhammad, Anas. Everybody. So means that maybe the person that present today, next lab, maybe other person to represent the group. I'm not sure how you want to coordinate between your lab mates. I'm not sure, maybe you have other lab individual or exclusive group, WhatsApp group, or what any kind of medium to communicate between you all. But on presentation wise, one person to represent the group. So maybe next group, next session, another person to represent the group. Okay, this time siapa nak present? Anybody?
Saya nak tanya untuk yang nak dapatkan 2 cycles tu macam mana? Lupa. Sebab dah buat dah. Cuma nak dapat kena tukar dekat simulation control dia kan?
The top name should be the leader lah. Anis Farzana, you sign lah. Siapa Rusdi kah? Khairunisa kah? Mak Nas kah? Want to present now? Oh, tu dekat dia punya tu plot 2 cycles tu 0 to 4. Satu dekat simulation control. So that's the way lah. Satu lagi, you boleh set anything dekat simulation control tu. But during scene view, you have to set dekat X axis tu you want to present from which hour ataupun from which duration up to which duration. So that is two ways. No? Either you set at simulation control or you set during simulation. Sebab tu yang mana dulu dia rectify. Hai, siapa? Mak Anas siap. You just present your circuit, then present what you simulate, then explain from that. You don't have to put or generate any report yet. Just present the circuit, explain what other circuit.
Khairunisa present.
Nampak ke?
Then you just present the result.
Okay, ni circuit. Okay, ni components yang pakailah untuk resistive.
Details.
Ni result yang dapat. Ni.
Quantitative. Of the result.
Sir.
Sekejap, belum keluar lagi.
Oh, okay.
Tak nampak. Tak tahu yang lain. Tak nampak sini.
Sekarang. Nampak tak lagi?
Okey, Khairunisa, mula semula. Saya pun nampak ni.
Okay, kejap okay, ni circuit yang untuk resistive load.
Okey,
Okay. Lepas tu ni untuk result.
Result tak keluar, tak nampak.
Tak nampak. Okay, jap.
Nampak sekut je tadi.
Result.
You present screen tak apa? Present screen. Boleh? Hello?
Kejap sir.
What happened? Present screen apa? Present your entire screen.
Okay sir, ni result yang kami dapat. Betul ke?
Apa komen Rizak? Tunjuk dan komen lah. So everything that you show or everything that you present in report, you put in report, there has to be some explanation. And is that you have to understand lah what you have to comprehend the audience in terms of what you want to deliver. Sekarang you apa nak cerita dekat audience tentang result yang nampak ni. So dia kena faham apa yang dapat kan. Tunjuk untuk memahamkan audience tentang apa yang faham tentang benda tu. So apa yang faham kat sini? How you want to explain? You have source 50 Hz, 50 volt. Okay, you have load of certain value. Then you run, you dapat summation untuk current, BP1, voltage dengan power. So you dapat macam ni. So apa yang dapat explain? Ke you pun tak faham? Teammate ada bantuan?
Sir.
Apa?
Daripada result ni, apa yang saya faham, voltage dengan current waveform dia perfectly in phase antara satu sama lain.
Ya. Lain-lain? Soalan lagi? Tadi siapa Anas lah?
Saya.
Lagi seorang teammate tak ada komen? Okay. Okay, first comment untuk circuit just now, we shall keep the comment for the ni lah. Okay, circuit okay lah. Tapi untuk result, okay. Untuk result, okay, when we perform simulation, the simulation is prior or preliminary step to make sure that our prototype or our product to behave like what we expect, or theoretically we learn that the such converter will operate with this performance. So to prove the theory, we perform simulation first. We can do prototype, but it's a costly step lah. Kan? Kita buat circuit, kita buat prototype terus boleh, tapi it will cost a lot. Kalau prototype, kalau misalnya teori kita tak betul, prototype akan burn. So it will cost a lot lah. So what is the safest step is we do simulation. So to perform or to prove that our concept or our theory is okay, so we have to do simulation. So how long the simulation should take place? The longest possible. Faham tak? Tapi dalam part ni kita buat hanya untuk 2 cycle. So untuk simulation proof test tak cukup lah. It's not enough, not sufficient, just 2 cycle. Okay. So the safest or the best simulation, the longest possible. Tapi the constraint is that maybe our simulation will take longer time lah. Maybe it takes hours or days lah. So that's for simulation. But for presentation, so we cannot, or it is not suitable to put all the 1-day simulation result in 1 frame. Okay. So how long the duration or the simulation frame that we should put in our report? So that's the question. So how long? So the best is that when we present the frame or the result, we can see the waveform. At least 2 cycle up to 5 cycle. So sekarang you punya cycle berapa nampak sekarang dalam frame ni? Kalau kita punya kita punya source, our source is 50 Hz. So your presented frame sekarang ni is just from 0 second to 10 millisecond. So 1 cycle for 50 Hz is how many millisecond actually? Theoretically. F equal to 1 over T. Faham tak? Or T is equal to 1 over F lah. So your F is 50 Hz. So your T is how much? T is equal to 1 over F. So how much?
0.02.
20. 0.02 second.
Yeah.
20 millisecond.
Yeah.
So at least you have to present how many millisecond? Like I told you before.
20.
It's 2 cycle. 20 millisecond is 1 cycle. 40 millisecond.
40 millisecond, 2 cycle.
So sekarang kalau you measure sekarang ni, you just present in half cycle. So half cycle you cannot say anything to the audience lah, because you're not presenting your operation of your computer or your circuit lah. And yeah. Okay, you have to extend your result or your frame up to at least 2 cycles. And these 2 cycles by right should be taken or extract from the condition when the circuit is already stable. Dia dah stabilized. Dia dah steady state. Get me or not? Dah steady state. Sometimes when we run the simulation, it needs sometimes to ramp up, ada spike, ada spark, and ada dip, ada event starting. Sebelum dia capai steady state tu, before it reach steady state, it needs some time to stabilize. When we present, we just present on the stable or steady state condition punya pattern. Okay. Baru it represent the running condition of the system. Okay. So that's the among the important criteria for presenting your results. Okay, tak apa, we shall comment based on the next group. Okay, thank you. Siapa tadi? Anis lah. Okay, Anis Farana, thank you. So next group, G berapa? G3, G3, please. That's for G2, G3, come in. Any question from the floor, so can ask.
Test. Saya dengar ke?
Okay, dengar.
Sekejap ya. Okay, hi, this is the drawing for the inductive load. For the simulation control, we are using 0.04 total time because we need to rewind the 2 cycle. So this is the cycle. So,
Okay.
tapi
Okay, in terms of your result, you can comment on result. Peak average RMS.
Start now. Voltage and current are out of phase by 90 degrees, means that the voltage leads the current by 90 degrees. Voltage leads the currents by 90 degrees. They also reach the zero value at different times. In the first half cycle, it absorbs power from the source, but in the next half cycle, it supplies back the same power to the source. That's all, sir.
Any comment from the floor?
No.
Teammate,
Okay.
ada? Teammate dapat graf yang sama? Pattern shape yang sama? Okay, we take a look at the result. Okay, when we want to present the result, actually we shall follow the flow of how we want to explain to the audience. Okay, means that the arrangement of the result as well have to follow the flow of current, right, in the simulation. Okay. Means that we're supplying the load with voltage of 50 volt. So the voltage pattern should be at the first row, then follows by current. Okay, some more idea or things to put into concern is that when we want to compare in terms of what's called the response of current and voltage, we want to measure or we want to indicate that as we know that if we run on an inductive load, the current will lag, and the current will lag or the voltage will lead the current by certain degrees. So by right, if you want to show that kind of result or discussion, we should overlap the current and voltage on the same frame, and should be overlap on the same frame. Is that one screen, we put both curves together, then we can comment in terms of their lagging or leading. So we can put the measurement legend on the graph itself, where, how much, and the lagging or leading values. And okay, like that. And provided also if but sometimes when the values the parameter is too much, the big difference means that when we plot voltage, we can measure or we can visualize the output. But when we plot the current over there itself, the current might be, in real case, it has a sine wave pattern. But when the value is too low, we can see just a straight line. So better in other frame as well, you have to put the waveform of current as individual graph lah. And to represent the lapping duration, you can overlaps, but to represent the data reading of the current values, you have to separate. And so maksud ada 2-3 frame lah. And the frame or the result that you present must be follows by comment. So the things that you understand, you can comment, you can explain, so you put. If you don't understand, you cannot comment, so better you not put lah. So it will trigger from the panel point of view question lah. They can question what is the graph telling all about. You want to explain what? So if you cannot explain, so better you not put in lah. So when you run, the most basic things you have to probe or you have to explain is on the voltage, current, and power. So this is 3 main things lah, parameters that you have to analyze in terms of power electronic converters. So the other criteria is that on the unit of the parameters. So you can see X1, X2 here. What does X1 and X2 mean? Siti Nabila. Dia read apa ni? X1.
S1
X2,
tu,
dia read apa ni?
okay.
Apa reading dia?
S1, this one, the first line, okay. You can easily remove lah dekat mana. Macam contoh kalau nak dekat I1 tu peak, dekat peak I1 ni. Lepas tu I2 yang satu lagi ni. Dia macam time, apa nama dia? Dia macam limit
Real time.
macam so nanti daripada situ dia akan ambil average lah. Betul ke sir?
Okay, X1 it reads the peak or the instantaneous values of the curve. Nampak tak? So
kalau kita
if you
gerak
shift the X1, memang dia akan read that cross line of antara curve. The curve tu dengan line tu. That is the crossing values.
Okay.
Instantaneous value of the curve. Kalau I lah, kalau V lah, kalau power lah at that time. At X1 punya timeline lah. Okay. So X1 and X2 also will represent, kalau you tengok X1, X2 is the instantaneous value. Means that kalau graph ni, if you look at the graph will represent the peak value of current, peak value of voltage, peak value of power. Am I not? Then the delta is your average. So average, delta ni apa dia? Average kat situ kan? Delta ni apa dia ni? Delta di different kot, different. The average is taken between X1 and X2. Nampak tak? The RMS also will read between X1 and X2 time frame. So for your best simulation, X1, X2 should be placed where? Nurul Nabila, kat mana? Nurul Nabila, S1, S2 letak kat mana untuk best result simulation? Nak dapatkan average dan RMS value ni.
Dekat stabil kan sir?
Stabil. So kalau ikut yang sini nak letak kat mana? Mana ultimate ni mana? Nurul Nabila?
Mic dia, tak tahulah saya dengar ke tak, dia macam pelan sikit. Sekejap saya mute lah, saya suruh dia
X1, S2 tak mana? Siti Nabila?
Tapi saya letak ikut macam kalau I1 saya letak dekat peak dekat 10mm dengan 30mm, 10M 30M. Kalau VP saya akan ubah lah dia dekat depan sikit. Lepas tu dia pun, ataupun kat sini. Boleh kan sir kan? Macam kita ubah-ubah kan?
Okay. The best result can obtain when we run the longest possible and we take during steady state. After it reach steady state and up to the longest or the end of simulation time. Maksud kata kalau kita run 1 jam, dia nak stabilize tu mungkin ambil masa 30 second. So after that 30 second, kita ambil as X1 and after it finish 1 hour, so that is X2. Nampak tak? After it reach stabilize and up to the end of simulation. Tapi untuk as of this example, so the end of simulation will be X 40 millisecond lah. So that is the place of X2. X1, okay, X1 should be, you can see that if it ends, if you refer to VP1, as your reference. So if it ends dekat 40 millisecond at zero value, so X1 also should be taken at zero value as well. Maybe at zero, kalau if you consider as the curve is already stable there, or maybe at 15, what? At 15 lah? At 12 ke? Ini bukan 12, at 10. No,
So,
no, 10, at 20.
20.
At 20. Means that same respond. VP is rising at 40, but it crossed zero kan. So at 20 also it rising and it crossed zero over there. So baru you punya result akan nampak ataupun akan present the real reading of RMS average like that. Okay. But if you are simulating in 1 hour or 30 minutes of simulation, any point you put does not bring any difference to the readings lah. Tapi kalau you just present in 2 cycles, so you have to be careful lah, and such that the simulation result that you present is a correct result lah. So that's the step or method. Okay, ada apa nak tanya?
Tak ada, sir. Sir, maknanya kalau kita nak cari macam X1 ni lagi senang kita combine graph untuk voltage dengan current kan. So kita nampak dekat intercept ni, kita ambil start dekat sini lah kan.
That one can be used as a reference as well lah.
Okay.
One of the way lah. Okay, some more when you take a look at your module tu, we have marking values, 4 mark, 3 marks, and at the end of the task lah. So if from the evaluator point of view, that 4 marks, actually when you produce the graph, you have that 4 marks. But when you do mistake, they will slash 1 mark, maybe 0.5 mark, based on the mistake that occur inside or from your result. So let's say you're presenting this kind of graph or this kind of output. So if let's say you are producing different or a wrong graph, so you not get marks lah. Maybe you get a format marks for the graph itself, maybe 1 or half mark. Tapi kalau different, totally a wrong result, no marks lah. Tapi if it is a right result, but you accidentally you maybe put a label cosmetically and it's too small in terms of labeling, or the graph itself you put in a same pattern, you expect that maybe for the report wise lah, you have to put legend. You cannot put colors only as to differentiate the lines, because when you print out, you be print out in black and white only. And when you put colors, so you cannot differentiate when the curve overlaps each other. And so you have to be wise lah, and to put the graph in legend, ada tanda dia tu, dan juga and what else label semua tu, dan juga placement of the graph lah, the flows of the graph. V dulu, I kemudian, power kemudian kan. Kalau tidak, dia akan mana kata you punya the perfectness of the graph is reduced, so maka pun akan reduce lah. Okay. Okay, itu saja. Okay, next group. Siap lagi tak sempat habis. Abdul Shakur is not available yet, I think. So next group, B5.
Yes, Doctor, can I proceed?
Oh, you have already. Okay, proceed, Abdul Shakur.
Later I can see my screen.
Okay.
This one for the capacitive load. Voltage and current and capacitor is here. So try simulating for I got this waveform for current and the voltage. What we see for here is starting for the voltage is starting for the zero and the current after the um, current is starting after voltage. Means I'm measuring for the maximum. Later, can hear it? Hello?
Yeah, can. Proceed.
But it doesn't show me for the for the X1 and X2 and average. I'm not sure it's different for the version that I use it. So this
So
one
where is
is
your X1 and X2 axis? You use which version, this one? Can you click the help button?
where is the data?
The top rows legend there. Help.
Yeah.
The help icon.
For
Right.
the level?
Right. To the right.
Okay.
Windows help. No, that's to the left. Right.
Here.
One more tab. Help. HELP.
Oh, yeah. Okay.
About. Click the about.
About, okay.
So which version you're using? 9.0. Oh, different from the version that we share, the latest link.
Oh,
Never mind. Okay, for this version, actually, we don't have this is the old version. We don't have X1 and X2, means that it reads directly
Yeah.
from zero, from starting of your simulation up to 0.04.
yeah.
So you don't have the X1, X2. You have to take note that.
Okay.
Maybe you have to download again, or you can use this one as well directly. Doesn't matter. But you have to turn note that when you simulate, so
Yes.
the reading will take place on your entire screen that you presenting or you simulating or you present here. If you generating a frame from 0 second to 0.04 seconds, so that's the reading of your result, average value, RMS value. Okay. Okay, for your power, you should put in your what's so called formula icon or tab to multiply V multiplied by I. Then you can get the
here.
curve of power.
Okay.
And the frame just now, you just overlap between current and voltage. Okay, what can you comment between on this result, comparing voltage and your current? What you can comment?
For the current, for the voltage starting 0 for until the maximum started until 45. But if the current is started discharging when the voltage is the highest number is 45. I'm expecting, and so the capacitor is starting for discharging until here for 25. That what I understand it.
Okay. In terms of your comment,
Yes.
in terms of the arrangement of the output, so you can arrange like that. We put the result based on what we deliver from the source until the end of our load. from the source, add the converter, then load. So that's the flows of how we should present our result. Okay, in terms of comment for each of what we observe here, when we put the graph or when we put the result, we have to comment. Below the result, we have to comment what are the graph or the shape the producing or is presenting. Okay, what the comment we should put on the comment is that on the quantitative and quantitative comment is that what are the fact and figure that we can observe or the result is showing. So now we have to understand that this curve is showing the peak value or instantaneous value. So we can see that if we want to comment on the voltage, we can comment that we are delivering the load with the sine wave shape with a peak voltage of 50 volt. Okay, 50 volt, pure sine wave with 50 volt. Then the current that flows into the load absorbing and or delivering. We can say the load is absorbing, or we can say that the source is delivering. How many peak in terms of current? And if we can mention also in average and RMS, also we can say how much the average current, the peak, the RMS current. Okay. Then we can say if we have the shape or the curve that overlapping between voltage and current, so we can comment also in terms of how much the degree that the current or the voltage is leading or lagging each other. Okay. So means that the quantitative of the graph and the fact and figure that we observe, so that's we comment on the comment side lah.
Okay.
Nampak tak? You can see? Okay, thank you Abdul Shakur.
Okay.
Next,
Okay.
final group. G3B5, Hisham, Badrul Munir, Ahmad Nabil, siapa? Want to present?
Boleh saya.
Badrul Munir, okay.
Yang ni sir.
Okay.
Lepas tu dia punya result yang ni.
Explain lah, tunjuk, explain.
Okay.
Explain. Okay.
Okay, so ni soalan D. Impedance, dia nak kena cari untuk ini.
Slow down.
Dia ada libatkan dengan capacitance kesemua lah. Dia punya capacitance, inductance, resistance. So dia punya circuit akan jadi macam ni. Nilai 5 semua based on table. And then total time ambil kosong 4 untuk second untuk 2 circle waveform, and ni dia punya result lah.
So quantitative comment apa dia tentang result tu?
Quantitative.
Apa yang komen, boleh komen tentang result tu?
Oh, komen yang ini ya.
Present the result. Apa komen dia? Apa yang observe? Briefly compare or your observation. What you can say with the result that you obtain. You boleh tengok result, you boleh tengok average, RMS reading tu. So apa komen you?
Average RMS ni Sekejap. Saya nak Saya tak tahu cara komen.
Betul lah. Okay. Okay, kalau ikut teori, kalau ikut teori, if we run a resistive load, resistive load, we shall have voltage, current in phase. Okay. If the load is inductive, so theoretically we can imagine or we can expect that the load, the current is lagging inductive. If we run with a capacitive load, the current is leading. Okay, if it is an impedance load, so it depends on the values on or arrangement of our inductor and capacitor. Which one bigger, so it will dominate lah. If your capacitor is bigger, so it will lead. If you have a balance between capacitive and inductive, so you will have a pattern or behavior dominant on the R itself only. So it just in phase lah. If inductor is bigger, so it will lag as well. Okay. However, you just can just confirm the leading or lagging based on simulation. So once you simulate, you can measure itself. And dekat simulation tu, you can measure. So how much in terms of leading ke, lagging ke. And so the graph itself will show you in terms of peak value, voltage of the system, how much it raise up to. And so you can comment in terms of how much peak value X1, X2 tu, it will tell you when you measure at that point, how much the peak value. And you can click the peak, next peak. Nampak tak? Kalau ada curve dia kan. Then average is the average between X1 and X2. Kalau you tak, if you put X1 at 0, X2 at end of your simulation, 40 millisecond tu, so that's the reading of your average value. And RMS also the same. So that is the amount or the data that you should put inside your comment. The figure and average berapa reading dia, RMS berapa reading dia, the peak of your, the highest peak of your current, voltage, power berapa. Your circuit ni, is it a circuit that absorb or use power, or it's just like capacitor or inductor only, which is not a real load, but it just what's it called, storage. And you tengok kan, kalau you run dekat capacitor load ataupun inductive load sahaja, it not consume any power, it just a storage. Dia akan absorb power, release power, absorb power, release power. Average power is 0. So sekarang tengok, kalau ada average power 0, maksud kata dia adalah storage. Kalau average power still ada values, you have values, so this is, it consume power lah. Nampak tak? So means that we have to alert on what we generate, how to comment, and we have to be aware lah. So faham tak? Because later from our theory we simulate, from simulation we shall produce prototype, and prototype untuk counter check our simulation and our theory. Faham tak? Prototype done, okay, baru kita akan pergi kepada mass pro, massive production. Okay, so engineer kena tahu semua ni lah. Kena be alert lah. Okay, ada soalan daripada lain-lain? Kita akan proceed ke lab 2 as well. Lab 2. Kita ada tiga komponen tu. Ada soalan? Munir ada soalan ke?
So far tak ada soalan sir. So far saya faham macam mana nak present sir.
Okay, thank you. Kita akan pergi lab 2. Bagus. Lab 2 boleh buat. Okay, pergi kepada lab 2. Buka lab 2 punya part. Okay. Okay, lab 2 is a task on how to understand the characteristic or the response of three different devices that we shall use in our power electronic converters. One is diode, thyristor, MOSFET. So you have 3 group. 3 ke group you? 4 3. You have 4 group. 2, 3, 4, 5. Okay, doesn't matter. Okay, 3 grup pertama. 3 grup pertama buat yang ni. Simulate untuk diode, thyristor and MOSFET. Kan? Expected schematic untuk diode, the source is the same, 50 Hz. You use 5 ohm resistive load. Then run untuk diode. Kan? You put the load, you put the source, then you put in between the load and the source is your diode. So you run on how many cycles? 2 cycles. Okay, 2 cycles as well. So the previous circuit, you just put in your diode, put in with control, put in your MOSFET with control. So you simulate and show me the result in 5 minutes. Okay, 5 minutes. Untuk group GB5, you also do the MOSFET. B2, B3, B4, B5. B4 and 5 do the MOSFET task. In 5 minutes, I'll call upon you to present. Okay, thank you. I give you 10 minutes lah, 10 minutes. Okay. Nanti present 2 minit setiap grup. Okay. Group 1, you may present your result. Group B2, Anis Farzana dengan Khairul Nisa. Tadi siapa? Anis kan? Khairul Nisa pula.
Untuk diet kan, Sir?
Ya, Dayak.
Okay. Ini circuit untuk nak run untuk yang A punya diet.
Then result.
Sekejap, Sir, untuk result. Okay, ini result yang untuk circuit tadi. Untuk voltage ada 2 cycle. Untuk positive cycle, diode conduct and the input voltage is appear during kejap, Sir. During negative cycle, the output at current will become 0 like yang dekat I2 punya. So for the graph for power sama macam dekat current punya, dia punya bentuk graph.
Okay, return to your circuit. Return to the circuit. Show me your circuit back. Okay. Okay, based on the circuit, sekarang when we perform the simulation or we perform our design, we shall theoretically will draft from our sketch lah. We sketch, drafting, then we put in simulation. After that, the next step is we put in prototype. We build prototype, then we build the actual finished product lah. Okay, in the simulation, so this simulation actually, as engineer, we shall produce schematic diagram, and it will be you or other person that will proceed with prototyping. And so means that you have to sketch exactly how the prototyper will do their job. They can follow exactly as your sketch. So you should expect the result based on your what you sketch or what you give them lah. So means that the placement of the component, the meter, you should be alert where you should place your meter semua tu. Apa tak? Okay, sekarang kalau basic converter, kita akan ada load, which is now is R. Kita ada source, which is now is 50 ohm, 50 hertz source. And we have our converter, which is the diode lah. So the system lah. So when we want to present, by right, we should present from source down to the load. So what kind of presentation that we have to highlight or we have to present is in terms of their voltage, current, power, signal, kan? So we have two voltage probe here. We need to probe. One is at the load, another one is at the source. Load and source. So now you have the load, the source voltage parameter probe, but the source you don't have. So you have to put, the load, the resistive load tu tak ada. So you can put the voltmeter at the load. Mana? Boh. Satu. Okay. And some more by right, we have to put current at the input and output as well. But for this system, if let's say we just put at the output, at the load, sufficient lah. Because the pattern of the current that draws from by the load from the source, if measure anywhere, is almost the same lah. And so one probe, one ammeter, but two voltmeter should be allocated to measure what we deliver, to measure what actually the load is consuming. So the V out and V in, and the I load lah, actually I load. So you can click simulate again, it will generate again the result. So show me the result.
Sir, dekat source pun kena ada ammeter ke?
By right, if you have a complex system or circuit, we should measure also at the source. But for a simple converter circuit, sufficient lah, cukup untuk dekat load sahaja. Because if we put the ammeter at the source as well, untuk simple circuit, and it will show the same exactly apa yang we measure dekat load lah. And if complex system, for sure it is a different measurement lah. And same goes to when we want to measure the actual system, we need to measure the efficiency. So we have to measure the P in versus P out. P in measured by how? By measuring the current and voltage kan. Also P out, voltage and current. So we have to measure lah by right. Have to have ammeter and voltmeter both side. So if you take a look at the output, at the result here. So the step to present your result is by following the flow from the source, which is now P2 is your source. Okay, P2 is your source, your input. So you have to label accordingly later as V in. So V input, and your maybe follows by V out, and V out and I out, and also and last kali is your P out. Okay, if you can see that when you measure at V in, you are supplying pure sine wave to the system, but when measure at the load, the voltage that pass through the load is only on the positive cycle. So what the converter do is that it passing the positive cycle, but it's blocking the negative cycle of the current. When positive bias, the current flows into the load, but negative bias, the current is blocked by the diode. So this is the what's so called. So in terms of comment, that's your comment lah, and how you can see or comprehend from the graph. So you translate ataupun you explain in words. Sekarang dalam figure, you explain in words in terms of their fact and figure ni kan. You put in comment. Okay, apa yang di sebalik circuit ni, apa yang what you have to understand is that we are trying to investigate what is the behavior of our non-controllable or uncontrollable device for this diode. Diode is the device which is categorized as uncontrolled or non-controllable device. Means that the behavior of diode when bias, it will allows or it will conduct the current. When reverse bias, and it will block the current. So that is why we are getting a positive bias or positive curve only. Negative curve, dia zero. Nampak tak? Zero. Okay. So if we put capacitor as our filter later, so we shall get a average values lah. And if you put measurement, so you akan dapat average values based on the graph lah. Okay, this is behavior of non-control or uncontrollable device. It allows or conduct positive bias. It blocks negative bias. Ada soalan? Kalau you run dengan inductive capacitive load pun sama juga. Positive bias of the flows dia akan conduct, negative bias dia akan block. Cuma you akan nampak, you can see that the current and voltage are leading each other. That's all. Okay, next for next group, B2, B3.
Sir,
Okay.
kiranya kalau untuk discussion kita kena cerita lah waktu diode tu on dengan off macam tu. Waktu positif dengan negatif.
Okay, discussion based on graph that you producing. Kalau you lump all together the graph macam ni, so you kena cerita lah daripada atas tu, daripada source, voltage, current, power semua tu. Tapi kalau you letak asing-asing, you letak source sahaja, so you comment the source itself. Voltage dia bentuk macam mana, peak value seberapa, RMS, average. Banyak benda you boleh comment. Nampak tak? In term of dia punya fact and figure yang you observable from the graph sendiri. You tak perlu untuk for the time being, you tak perlu lagi conclude, tak perlu lagi include yang bukan di situ. Secara teori tak masuk lagi. Dekat conclusion baru you masuk, you campur dengan teori yang tidak tersurat dekat graph tadi ni. Untuk comment for the time being, you comment apa yang tersurat, which appear only, not what is behind that. Faham tak?
Faham.
Okay. Okay, next group. Siti Nabilah dengan Nurul Nabilah. Okay, Siti Nabilah.
Sir,
Okay,
betul ke drawing ni?
Okay, V in ada, V out ada. Okay. Current by right letak dekat after the converter, after the device. It still will measure the same pattern, tapi in term of arrangement by right, that is the correct way lah.
Macam ni, sir?
Okay. You will still producing the same output. Okay, explain your result.
Based on the result, the value for voltage at load and current, the cut off time is same, which is from 10 milli to 20 millisecond. Meanwhile, for the voltage at the source, there is no cut off time.
Tunjuk circuit balik. Okay, when we involve a processor in between our load and source, so we assume that our simple diode thyristor and the gating is the system or the converters. So we have to present as well the source signal into the simulation result. So you have to put one floating voltmeter, volt probe on the source, on the gate. Put dekat gate tu, so simulate semula. No, the gate that is on the terminal. On the gate.
On the key.
Triggering gate.
Ini. Oh.
Dekat echo diode thyristor tu. Thyristor, kalau you double click the thyristor, Okay, tekan help. Enlarge. Oh, tak ada sikit sini ya. Okay, dia ada dekat mana tu floating current. Tu yang anode, cathode, then the third terminal you connect to the simple square wave tu adalah gate. Dia punya gate dia.
Okay.
Gating dia.
Ini
so that's the gate. Okay, simulate semula.
Sama ya.
You kena add lah gating punya tu.
Oh ya. Yeah.
Just add frame. Nampak tak?
Ni ke?
Why that's V3. V3 kan? V3 gate je. So why you're getting to, tengok dia punya frequency gating berapa letak?
50.
Double click kat gating tu.
Oh, gating ni tak. Oh.
Tu 5000 kHz. Patutlah.
Rasa saya lupa nak tukar tadi sekejap.
Yeah. 50 Hz. That's 50 kilo. That's 5K. Semula. Okay. So let's say this is the correct signal lah. Assume lah. So in terms of arrangement, okay, like I told you before, we follow the flows from the source up to the load. So the first is V in, then the gating, followed by the gating, then your V out and I out. So the gating should be on the second row. You can delete the curve or you can replace the curve punya content lah. Double click the curve, you just replace. Double click at the frame. Double click. Nampak? Delete yang mana tak perlu, masukkan mana yang nak replace. You can double click je, dia akan masuk. Double click, dia akan remove. So yang B
satu.
The last tu you tak voltage lah. IMV belakang sekali. Okay, sekarang you buat storytelling lah. Daripada source sampai ke output tu.
Tak tahulah saya.
Storytelling. So we are delivering a pure sinusoidal wave to the load of, and you kata you delivering pure sinusoidal source of 50 volt peak and to the load of let's say 5 ohm. Okay, so you dah cerita untuk part 1. Then the triggering take place at 90 degree, ends at 180 let's say on each cycle. Then the system is producing a curve of current which triggers to switch on at 90 degree and ends at, ataupun dalam degree ke dalam second kan, at 10 millisecond. Nampak tak? 10 millisecond. And it returns to 0, then it rise again at 20 berapa millisecond tu. Rise again up to maximum of 10 ampere and down to 0 again. Masa kata graf yang nampak ni, you just explain dalam bentuk karangan, dalam paragraf, dalam explanation. That's all. That's the explanation of the comment of your, to accompany this graph or accompany the figure that you present. Tu je. Kadang bila audience tengok benda ni tunjukkan. So you just explain lah. Apa yang you dapat tu, yang you faham dari situ, you explain. Just explain the figure and fact. And kalau you letak measurement, you explain lah. Sekarang ni yang dia tunjuk, it shows now is in peak, instantaneous value. You can include as well in RMS or in average reading. Okay. Okay, sekarang apa di sebaliknya ialah what's behind the picture is that we are trying to understand in terms of the non or semi-control device. Semi-control device. This is for resistive load. Tapi if you use other than this resistive load, let's say impedance, other components of C and L, you can see that there's a tail on the I current, which is it will not end at zero. It will end after maybe it reach negative cycle. So the behavior of our semi-control device is that it will switch on when we put a trigger, the signal trigger to the gate. We refer to V3. When you trigger the device, it will start conduct. Nampak tak? During the triggering point, it will start conduct. But when you take out the signal, nampak tak? You take out the signal is no more triggering the device. Still there is a current. Also the voltage conducting throughout the circuit. Nampak tak? Is that the semi-control device, what it does, it just trigger on, but the switch or the system will zero after the current cross zero crossing. Nampak tak? Dia trigger by device, it's switch off by, or it's on by device triggering, it's switch off by current when it reverse bias. Current reverse bias baru dia akan off. Dia nak on bergantung kepada when the time that the device is triggered. Dia nak off, it depends on when only the current is reverse bias. That is the behavior of semi-control device. Apa nanti ke depan kita akan buat lagi eksperimen untuk lebih memahami tentang behavior of the devices lah. The different of the devices. Pukul 5 dah. Okay, next final group. You ada berapa lepas ni? Pukul 5 ni. Sorry lah for the delay. Final group. Siapa? Abdul Syakur ke ni? GB5 dulu. Anybody?
Yes, sir.
Okay, Abdul Syakur. B5 also just show a little bit later. Then we just dismiss the class lah. Sorry for the delay. Sampai 5 lebih sekarang ni. Where's your circuit?
Yeah, this is the circuit.
Why you have two source over there?
What? Yeah.
No, two source. Why you need two source?
I'm looking.
Okay, double click at your signal, your triggering signal.
This signal.
No, your triggering gate signal, gating signal.
Okay.
Simple square wave gate.
This one.
Okay, 50 Hz, 45 to 90. Okay. Actually, your placement of MOSFET is incorrect. Akur.
MOSFET. Okay.
Yeah, MOSFET placement is incorrect.
Oh, this one.
Yeah, you have to
Yeah, I can
invert. The incoming is other side.
for making flip.
Gate, what's so called drain and source is different. Yeah, should be no. You have to rotate again. Rotate. Again, one more. That's the correct way. So it enters from the drain to the source. Okay, run again. So, explain. So, where is your V in?
This one will be in.
Where is your V out? Yeah, just now there's your V in, but what is your label for that V in? Just now.
Yeah, I didn't see it.
You try to undo. Just now. Just undo. Okay. Double click. Double click V. That V.
Oh, this one better.
Double click, yeah. So
Okay.
VP2, yeah. You just plot at your output just now, VP2. At your simulation result, same view. You open same view. Just now your result. Show your result. Okay, add graph. Add graph. Add graph. Add frame, add frame.
Oh, okay.
Yeah. Yeah, VP2. So that's your input. See? Okay, explain.
It's my first time for this one.
Do a storytelling. What you deliver, how it goes to the load, why you have, what kind of shape, voltage and current you have.
This one is MOSFET for our source is delivering for 50 volt. Yeah, it's 50 for peak for the source. When we looking this graph, it's really difficult to explain better for MOSFET. I didn't. And this one, for the load is 5 for resistor, but for the diode for MOSFET is the gate closing on starting for 0 for the voltage until reach for 50 just started, and the diode is open until it's how to now here between.
Okay, you can present in unit either in millisecond or in degrees. Okay, when you take a look at your result, okay.
Yes.
So just follow the flows of what I say from the left to the right or from the source to the load. So from the source means that you comment first or you put the result of incoming voltage, you comment on the voltage. You are delivering how much voltage RMS ke, peak ke, to the system or to the load. So you just mentioned that you are providing or supplying 50 hertz, 50 volt sine wave to the load of 5 ohm. Okay. Okay, when you trigger, so you have to put the triggering signal over there. So when you trigger at certain point, so the current is switch on. Okay, the current is switched on, and when the triggering signal is taken out, so the current is switched off. The pattern of current follows the pattern of voltage shape. can say that. But during negative cycle, you see at the input, at the result, you can see that the current is allowed to flow.
Okay.
So
For the
allowed to flow.
95 second.
From how many second to how many second. Then it repeats the same pattern of the previous cycle on the next session. So you can say that. Okay. So same goes to the comment for the voltage lah. Okay. So after that, maybe on conclusion, you can say that this is the behavior of the fully controlled device. Means that when you give the load, give the signal, it will switch on. We take up the signal, we switch off. So that's the conclusion of your observation. Okay. Okay, next group. How's your result? Siapa-siapa ada soalan? Anybody have question?
Result also.
Result and circuit.
Sekejap. Yang ni result kami sir.
Okay.
Dan ini circuit.
Okay.
Okay, sekejap.
So comment the result. Tengok circuit balik, tengok circuit. Apa pelik ni? Okay, double click dekat tu. So probe satu signal tu. Voltage probe, floating voltage probe at the signal.
Voltage ni ni.
No, voltage probe dekat signal. Voltage probe.
Voltage ni.
Voltage probe. Yang tu voltage probe antara node to node. Voltage probe satu lagi yang bawah tu. Yang voltage probe dekat single point. Dia macam jarum peniti tu.
Oh. Ini.
Letak
kat mana?
Dekat signal. Macam kita measure transistor tadi. Okay. Run balik. Malaysia.
Okay, Nabil akan present.
Run simulation balik, tengok result macam mana. Include the voltage probe reading as well. Mana assistant engineer?
Nak kita tengok waveform.
Waveform mana? Okay, susun ikut yang ni lah. B in, B out, I out, then P out pula ada. Just add screen ke?
Boleh alihkan?
Dia double click dia akan keluar. Double click dekat mana-mana, nampak tak? Sekarang you tengok B in kan?
Ya.
You kena run balik, B3 tak masuk tu. You kena run balik. Jangan pangkah run saja, dia akan reload semula nanti.
Okay.
Just run semula. Tak payah pangkah. Run je. Run balik, tekan tadi. Kan run simulation. Okay, run pun run ke? Double click tengok semula.
Kata dah run dah.
Run dah?
Run dah.
Tak ada, ada bateri, okay. Okay. Patutnya susunan dia, the arrangement is that from V in, signal, V out, I out, P out. That's the flow of kita punya story lah. Sekarang kalau you susun chapter, you arrange the chapter back and forth tak betul, so akan jadi keliru lah. Audience nak dengar kan. You cerita tentang permulaan tapi dia punya gambar duduk dekat ujung. Jadi baiknya susun ikut aturan lah. Kurang jelas komen. Siapa present ni?
Saya.
Okay.
Result dia akan dapat macam ni. Macam mana?
You punya V-in buat apa dia? Mula dengan negatif ah. You tengok V-in balik. Double click V-in. Tengok circuit. Okay, double click lagi. Oh, you punya V-in dah terbalik tu. Dot kat bawah, patut V-in dot kat atas. Apa dia sama je tapi it will give a different kind of simulation result lah sekarang ni.
Sama balik.
Patut dot ikut dot lah. Okay. Run balik, reload balik. Data tu, tekan data. Nampak okey lah. Baru nampak betul. Okey. Komen.
Ni graf dapat graf dia ni macam ni aja.
Lepas terbalikkan source tadi akan dapat positif lah. Yang V-in semua tu. Yang average RMS dapat yang ni.
Okay, kedudukan X1, X2 you kena take note lah. You have to simulate and you have to take the result, the frame. Actually, if you assume that the graph is stable or steady state condition, so X1 kalau letak dekat kosong, X2 letak dekat 40 millisecond. Sekarang you measure antara 10 dengan berapa tu? 30 millisecond kan? So it's not a correct result lah balik kalau ikut sini lah. Tu bagikan jadi result yang betul. Fully complete 2 cycles of result. Nampak tak?
Okay, sir.
Okay, you nampak tak? Bila kita this simulation, you boleh enlarge balik paling besar boleh, sebesar mungkin. This simulation is to simulate or to understand the behavior of fully controlled device. Kan? Fully controlled device. MOSFET is a fully controlled device. Maksud fully controlled device is that when we put or we induce a signal, we refer to your final curve tu, V3 tu. That is an input signal which we induce to the device. We put the signal or we provide the signal to the MOSFET. You're talking about the fully controlled device which is MOSFET lah. MOSFET, IGBT, MCT semua tu. We put the signal, it will switch on. You can see the V out is there, the I out is there. We take out the signal, so it will switch off. It will not be the same like a semi-controlled device just now, which is called switch off by reverse bias of current. Tapi yang ni, you take out the signal, dia akan switch off terus. Nampak tak? Cuma, it just like when it enters the negative cycle, all the conduction is there. The current is flowing. Positive cycle you can control. Negative cycle by right, actually because we don't put any signal to the system or the device, by right it should be 0 lah. But if you can take a look at the circuit itself, tengok circuit balik. Buka circuit balik. When you take a look at the circuit, you can see the configuration or the layout of the MOSFET. You can nampak diode situ. Nampak tak? Kalau enlarge kan nampak diode. Positive cycle, it behave based on the signal that you provide. But negative cycle, when the current returns from the load to the source, it will follow or flow throughout your diode. That is considered as your bypassing diode in the MOSFET. Most of MOSFET, they have bypass diode like this. But some MOSFET, by right, they don't have. Earlier MOSFET, they don't have this bypass MOSFET. But due to application in the computers, most of it, they need a reverse or bypass diode. So in the recent module of MOSFET, they include together the bypass diode. Tapi kalau ikut, if by right, we don't have that MOSFET diode inside the MOSFET. So due to the reason kita akan nampak, we can see that there is a current flows during negative cycle. Tapi the behavior of the fully controlled device, by right, we put the signal, it conducts. We take out signal, it will shut down. Fully controlled device. Understand?
Yes, sir.
Okay. Okay, later inside your simulation or inside your circuit, you have to analyze the circuit based on the load and based on the source that you're providing. Let's say you're providing the system with this sine wave source, so you have to simulate based on the cycle. So positive cycle, when you put into the circuit, you just trigger where the current will flows. And before it reach the load, dekat mana dia akan flow? Dia masuk dekat, kalau diode, dia akan jadi behave macam mana? Kalau tharistor, macam mana behavior dia? Kalau MOSFET, macam mana behavior dia for positive cycle? Bila negative cycle pula, flow current macam mana? Dia flow daripada source, pergi ke load, balik ke device, balik ke source. So macam ni, kalau dia ada MOSFET dengan reverse ataupun dengan bypass diode macam ni, for sure dia akan masuk dekat diode, balik ke source. So dia akan dapat graf macam you nampak sekarang ni lah. So maksud kata bila you dapat graf tu, you boleh analyse balik. Your circuit betul ke tak, ataupun behavior of circuit ni betul ke tak mewakili result ni dengan berdasarkan positive cycle and negative cycle analysis lah. Okay. Okay, that's all for today. Any question from the floor? Sorry for the delay. Makan masa sampai setengah jam lebih. Ada soalan? Okay, I hope that the discussion today will benefit you all for your future